school that I go to, we're not learning this until the end of the week, but I thought I'd still make a video on it just as a reference for the future. Integration by parts. So far in our integration journey or whatever, there's kind of two things we can do. First thing we can do is we can see an integral and we can kind of just know like that it's the antiderivative of a certain function. So for example, integral of 1 of x squared or 1 over x squared plus 1 dx, you just know, hey, if you take the derivative of tan inverse of x, that's what you get, right? So I know the solution to that is tan inverse x plus c. And if it's not something we can easily work backwards with, we can do u substitution. So if we're given something like, for a quick example, right, integral of cosine x e to the sine x dx, you could set your u as, sine x, du is just cosine x dx, and then you can evaluate it with u substitution. But what if you get an integral like integral of x to the e to the x dx? And your gut instinct might be, well, okay, let's set u as x, but then your du is just 1 dx and we have an x dx. So it's like, how do we approach something like this? We need another strategy to approach this, and the strategy we're going to use is called integration by parts. To show you where it comes from, first thing you kind of gotta recognize is that it's like the integral of like the product of two functions, right? So we have x and then e to the x, right? We know that derivatives and integrals are opposites of one another. When are we dealing with the product of two functions? When we're taking derivative, that's product rule, right? So when we're trying to find the derivative of the product of two functions, we use product rule. So let's try to work with product rule and see if we can kind of create kind of like a formula or some sort of way to approach an integral when you're dealing with products. So we know that if we have f of x times g of x, right? If we're taking the derivative, so if we're doing d of dx of the product of those two functions, we get our classic f prime g plus fg prime, however you want to memorize that. So it's f prime of x times g of x times f of x times g prime of x. So what we're going to do is let's integrate both sides. Now, why would I want to do that? Well, if I integrate the left-hand side, we know that integrals and derivatives are the opposite, right? An integral is just an antiderivative. So when I integrate the d of dx of the two product of two functions, that just kind of cancels out the derivative, right? Same way if we like multiply, like if I had 1/2 x, right? 1/2 x equals y, or x over 2 is equal to y. Dividing, I would do the opposite, which is multiplying to cancel that out. Same kind of vein of what we're doing. So we're gonna say f prime of, so that cancels out the d of dx. So you really just get f prime of x times g of x is equal to, and then you get the integral of f prime of x, g of x, plus f of x times g prime of x, and then we're going to do it with dx, right? We're integrating with respect to x. We can use our integral properties, right, to make this easier. So when you're taking the integral of the sum of two functions, right, you could just essentially distribute the integral, kind of. You could say f of x g of x is equal to integral of f prime of x g of x dx plus integral of f of x g prime of x dx. All I'm doing right now is just setting up or showing you where integration by parts comes from. We haven't reached there. We kind of reached there yet. We haven't reached its true usable form yet, but I'm just showing you that it comes from product rule, right? Like integration and their differentiation are really closely connected. An integration strategy we can use for the product of two functions just comes from product rule. So what we can do now is, well, we know that what we're trying to evaluate for is an integral. We're trying to evaluate an integral, so it doesn't really matter. Like, we want to solve for an integral. We're not solving for this, right? We're trying to evaluate an integral. We're not trying to evaluate the product of functions. So you can you can subtract this integral over that side. It doesn't really matter. I'll just do, I guess for simplicity, I'll do this side. I'll do this side. So if I subtract this side, I won't write it down. It'll take too much time. But I get f of x, g of x, minus the integral of f prime of x, g of x, dx is equal to the integral of f of x, g prime of x, dx. And this is really integration by parts. So there's these f of x's, g of x's, and all that stuff, and eventually we're gonna have to get to the stage where we're deciding what is our f of x, what is our g of x, that sort of thing. To make it easier, we use u's and v's. So let's say let's let u equal f of x and let v equal g of x. And then we can rewrite this in terms of u's and v's to make it a little bit more, I guess, easier, or I don't know, more simple. So f of x, g of x, that's just uv. So I'm literally just rewriting this now. So f of x times g of x, u times v minus this integral. Okay, how are we gonna do this? Well, I know g of x is for sure gonna be v, right? Now, what is f prime of x? And then, so what is f prime of x? Well, f prime of x is just, if u is f of x, then it's just du dx, right? You guys comfortable with that? If u is f of x, I'm just taking the derivative of u, f of x, with respect to x. That gets us f prime of x. So I know that du is equal to f prime of x dx. And I can do the same thing with g of x. So I know g of x is dv. I like to add the little tail for the v, or whatever you call it, just to differentiate them. So dv is equal to g of x dx. This is helpful because now I see, well, f prime of x dx, that's just du. So I can say integral of v du is equal to integral of u, right? Because f of x is u, and then g prime of x dx, that's just dv times dv. Okay, this is integration by parts. This is it, right? Like, this is the formula that, I don't know, depending on your school, maybe there's a textbook, or maybe they just maybe your teacher just tells you this is integration by parts. This is where it comes from. It just comes from product rule. So what I'm gonna do, let me just check how long is this video to see. 8 minutes, that's not bad. Wow. When I used to be making these videos, I used to be a really big, as a kid say these days, a really big yapper. I would explain way too much, so I'm glad I got this under 8 minutes. Now I'm going to show you how you can use integration by parts. So, okay, we are given the product of two functions. We got to decide what's going to be our u, what's going to be our v, so then eventually we can start substituting in the u's and v's correctly to evaluate. So here's the deal with choosing your u's and v's. You want to choose u, and I'm taking this from Professor Leonard. I watched his lecture over the summer. It's really good. You want to choose u so that the derivative of u becomes better, and that the v, you want to choose v so that the integral would be possible. So I guess I'll write this. So we want to choose u so that the derivative of u, so I'll say, I guess, du dx, I don't know, so that the derivative, I would say that the derivative is better and it makes it easier on us. And then we want to choose v so that the integral is possible. And I'm going to show you kind of what I mean with this example of choosing the u's and the v's. So, like in all honesty, this one's kind of hard because, or not hard, but it's like there's no clear thing to say what's going to be our u. Because if you take, let's say u is x, well, the derivative of u to the x, like, is 1. That's kind of better, right? But if we think about u as e to the x, well, the derivative of e to the x is e to the x. That doesn't really make it better, actually. So maybe this isn't that hard to choose your u's, right? I want to choose my u to be x. Because I know that eventually there's going to be like that du, right? And I'm going to want it so that the derivative is better. And yeah, I'm going to choose x because I know du is just 1 times dx, right? So it's just equal to dx. Okay, what about v? And then also understand, like, if I choose u to be e to the x, right? So if this were to be e to the x, then I know du is just e to the x dx, and it's like, yeah, that doesn't really make it better because it's like I still am I didn't reduce the problem. You know what I mean? Like I started with e to the x, I still have e to the x. That's not really helpful. So I'm gonna choose u to be 1. My duster's about to fall off. So u's an equal x, and then du is just 1 times dx. Okay. So here's the thing about v. This is what kind of tripped me up initially, or when I was learning this. It's like v, well, like instinctively when you go through this proof, you're like, well, it's a product of two functions. If my u is x, my v is e to the x, right? It's the other part of that, like the other function. But in reality, it's not necessarily e to the x. It's really everything that's left behind. So this is literally how you find the v. You hide the x, and then what you're left with is e to the x dx, the integral of e to the x dx. So my v is literally the integral of e to the x dx. So the reason as to why, because this is what confused me initially, the reason as to why we do that is because I know that really this is going to be in that u dv form, right? So if u is my x, so let's say this is my x, right? Then, so x is my u, then according to integration by parts, this e to the x dx is, this e to the x dx part is the dv. So this is my dv. So the, I guess one way you can kind of think of it is, okay, if we have dv is equal to e to the x dx, then I know dv dx is equal to e to the x, right? And then what's the opposite of like, the derivative? You know, that's the integral. So if I were to, I guess, not really integrate both sides, I'm thinking of a way to explain this. If we have dv equals e to the x dx, I guess what you would have, I guess I don't think my school teaches it this way. I don't know how my school teaches it because it's in a week, so this could be completely different. But whatever. If in order to find my v, I would have to integrate both sides, because it's like, then, well, I guess the integral of dv, right? If you take all the v's, you get full v, and then you get integral of e to the x dx. And then I guess I can show it like this. So if let me redo what I was just explaining. If I set my v to be the integral of e to the x dx, then I know if I evaluate this integral without the plus c, I get e to the x, right? That's pretty simple. Integral of e to the x dx is e to the x. Hopefully you're comfortable with that, just by the antiderivative. And then what is my dv? Well, my dv becomes, or if I take the derivative of e to the x, right? If I do my dv, it becomes e to the x dx. And that's why we choose the integral, so that when we find v, the dv ends up being what we have in here, our dv in our function. Hopefully that makes sense. Honestly, for me, I kind of have to wrap my head around that to make that make sense. So just with practice, you'll get better with choosing u's and v's. now let me just show you how this works. So, I have my integral in terms of like u dv, right? So I know u dv is really equal to the integral of x times e to the x dx. So now I can use, well, I know u dv is going to equal this stuff. I can just say that x to the e to the x dx is equal to u dv, which is just this stuff, right? So it's equal to uv minus integral of v du. So, and my v's, I gotta get in the habit of adding this because they look really similar. So u times v, so I get u times v is just x times e to the x, x times e to the x, and then minus the integral of v du. So my v is e to the x, and then my du is just 1 times dx, or just dx, right? So then you get it's equal to x times e to the x minus this integral. We know e to the x, it's just e to the x, right? And that's why we want to choose v so that the integral is possible, because you're going to end up integrating v eventually. So you want to choose v so the integral is possible. And then so I get x to the e to the x minus this integral, which is e to the x plus c. And there you go. That's kind of our answer. You can factor out the e to the x, so you really get e to the x is equal to x minus 1, or e to the x times x minus 1 plus c, however you want to write it. But that is how you do integration by parts. I'm going to make another video. I'm going to go over some more examples of integration by parts, so that, because yeah, the main thing that you got to practice is choosing your u's and v's correctly. Like this stuff, you don't even know. You don't even know this stuff. Like, you're not gonna be asked to prove integration by parts on a test. You're gonna have to skillfully choose, like, what is my u, what is my v, how do I choose u and v so that I can make it easy on myself. Thank you for watching. Hopefully you have fun doing integrals over the weekend.